right? So great improvement. I went bragging, right? I go bragging to my peer teachers, hey look, I did a good job on the order of operations question. She goes, yeah, we'll ask him. So let's see. Let me finish up here, and then I'll tell you what happened. I forgot about this here. The very next problem after this one. So this was on the exam. This was the next problem. 45 students got it incorrect. 45%. And that's pretty low. And that's not where I expected the year to be. Partially because, and I didn't keep good data on, I kept great data on how many people missed it, but I forgot to sort the data on why they missed it. I wasn't thinking like that at the time I collected the data. Some people did this. I want to say a memorable amount of students out of the 45% incorrect did that. Because they did the parentheses. Right? So 2 minus 8 is -6. I did the parentheses, man. Yeah, alright, so we took care of the left of the right thing, but we still struggle with parentheses. And most of them distributed a 4. I'm just going to distribute a 4. And again, it's back to this thing. Is the sign part of the number or not? I don't know. Let's see. This is what we came up with in our classroom discussion as we went over the test. They still think parentheses are something that are done. You do parentheses. Yeah, they're right. It's called multiplication, which is third in the order of operations, not first. So where are parentheses in the order of operations? Third. Okay. Show me how you do a parenthesis. If you're going to do a parenthesis, it's got to look like this. And then that's 10. That's how you do a parenthesis. Yeah.
But that's going to come from what we say. We say do what's in the parentheses first.
In the parentheses first. But again, what are they hearing? That overgeneralization.
Yeah, the do.
They're hearing P and PEMDAS. So that's why I say it's third, not fourth. Not first. The operation inside the grouping symbol is done. The grouping symbol always remains. That's another thing I started saying. So 2 suggestions. First off, teach the rest of the PEMDAS acronym. My students love this. It actually works. PEMDAS stands for Please Excuse My Dear Aunt Sally. Well, why do you have to excuse her? Did she fart? Is she a racist? Oh, she doesn't know math. Please excuse my dear Aunt Sally. She does not know math. Focus on the idea that there are only 4 steps to the order of operations. And build understanding at the same time. Pre-algebra. This is how it appears in my textbook. I don't see the word parentheses anywhere in any of the 3 textbooks I use. It does not exist. It says operations inside grouping symbols. And it gives a list of examples, for which I always make my students say, when I discover there's a problem with order of operations, I say, great, give me 5 grouping symbols other than parentheses. And I don't even let them put parentheses on the list. So I've got here, parentheses, dead last, just so that you know I didn't forget them. Okay, radicals, absolute values, division. Division is first. If it's written as an overbar, you got to do what's inside of it. Not divide, but do what's inside. Exponents, roots, absolute values are second. Multiplication and division as they appear left or right. That's kind of the traditional wording. I guess at this point, if you guys want to open up your things, you're fine. I just want to see if you'd say PEMDAS when I asked you what the error was. Did you? So if you need to take notes, feel free to use PowerPoint. When I'm teaching fractions, sign numbers, I start over. I say, hey, what's the order of operations? Well, maybe it's inside grouping symbols. Maybe it's to rewrite division by multiplication by reciprocal. Factor and then cancel, just like we did last time we were here in bonus. Or rewrite all subtractions as addition of the opposite. Right? That idea of changing the sign. So we don't have to worry about where division and subtraction are if they don't exist anymore. And that's a great thing to do while you're teaching both fractions and sign numbers. They have to know it anyway. Put it in the order of operations and kill division. Kill subtraction. And then when you're focusing on algebra problems, traditional solve a simple linear equation with parentheses and signs and x's and things that need to be collected, rewrite it again. Talk about it again. Start with order of operations all over again. What's first? Oh, the stuff that's inside. Oh, and then the exponents, and then you distribute, because if you can't do what's inside, then the way you get rid of or do the parentheses is to distribute. Then you collect like terms. So we got different ways we can say the same thing. It's the same 4 steps. Please, never more than 4 steps. But it doesn't always work. Despite my best efforts, this is the one my peer told me to use. Kind of jumped ahead a bit earlier, I forgot where it was. She said, oh, ask him this question. Remember my test question? The test question that all but 2 got right was 15 divided by 5 times 3. They got that right. But old habits die hard. Parentheses come first. And they got 1. And I didn't know what to do. I think I'm correct. What about correct answers? Hey, how much time?
Are you going to 5?
I'll go, I got about 10 minutes left. All right, I forgot to start my timer. All right, here we go. What about correct answers? Do we have to do error diagnosis on correct answers? Like the student on the left know what he's doing? Well, why not?
Because it's not really -7.
Yeah, it's not really -7, and if you thought it was -7, it shouldn't cancel with the 7. Right? So I don't think I think the 2's cancel, but I don't think -7 over 7 is correct. I think if they think it's -1, then I should see a -1 on their paper, and I know that because I see -1s on the papers of the A students. And just because this student gets a B, I don't think I should leave him out. He's not an A student. He got this question right, he got lots of questions right. He's not my best student. And I suspect it's because he doesn't write the -1. So we have to look for these things also, even if they're correct. How about that one? That's the right answer. Yeah, these are a little harder about what we should do. I mean, I know what we should do. We should separate the sign and the number factors, show that the sign is -1. That's already come up from the group today. But I know that this student also has a problem with these things. And I suspect it's the resistance to write the -1 factor. So how can we fix it? Well, how often do I really write it? On the board, in my work, how often do I really write the negative factor? Probably not enough. So how often should you write the negative factor? Every time. And we're lazy. How often do I use parentheses, or have I once again typed a dot because it's easier? So what we should do, what would clear it up, is often hard to do. I would say, let the parentheses slide. But let's start writing -1s more often. I think we could get multiple benefit from it over 2 different problems. I think it would solve both problems. Ignoring the error because it's the correct answer is a huge disservice to the student. I mean, yes, he passed the assessment. He got a B. Probably was very happy with his grade. I don't think that's the reason. This student also had a B at the time. At the time, she had a fairly high B when this assessment was given. She's now 1/10 of a point from failing my course. Her inability to progress, she is computationally very strong. She can sit there and answer any verbal question you can think of. 15 times 2, 36 times 8. Okay, computationally very strong. But she's not made any progression in algebra. She's maintained her current knowledge, but I've not seen any gains from when she first came into my classroom. She scored very high on the first few tests because it's introductory material. Right? And she attempts all story problems. I don't care what they are. By random combinations. 15% of 20 is X. 15 times 20, 15 divided by 20, 15 plus 20. I wonder which one of these is right. You know, I mean, this is her, and this is an algebra class. Our goal with asking that problem is to translate the percent to a decimal or a fraction, figure out where it goes relative to the equal sign. No progress there. And I think that that's what this represents, is a lack of desire to use the algebraic notation, understanding of the algebra notation, and frankly, when I approached this student, and she was defensive and argumentative. Why are you picking on me? I got it right. So what could we do? We could create a discussion. Okay, then answer this question. No problem. What is? So I just covered up her work, covered up the answer, and I said, hey, what is negative 14 over 42 divided by 7? And then we went through, and we eventually agreed that it was a different answer than what she got. But again, there's a high number, you know, we had to put a whole bunch of ones in here that she was fairly reluctant to write before we could see that. This was not my idea, but I think it's a great one. I could have brought this up. It was the division error, easily could have been a multiplication error. Make sure we see it both ways. Make sure that we can write it as addition. And those of us that are really clever can do the same thing with division and subtraction. It's just, I don't know if that's appropriate in this fractional example with these numbers. But this is the student who I struggled with absolutely most all semester. I don't have a copy of her work because I sent her home with it to practice it. And I didn't have my scanner available. But I remember the discussions very clearly. Because I have to say, all semester long, I thought this student was hopeless. I could not figure out what was wrong. And eventually I found it. But it took me forever. She's fairly consistent.
She's switching the numbers?
No.
Science.
There's something else about this student that I think you should probably know before we go any further. This student is the closest I've ever had to a first-time learner. I don't think she ever saw algebra before. Now, for me, that's a foreign concept. You teach kids who have never seen algebra. That's your job. I teach people who should have seen algebra. Maybe they smoked out a bit too much and they don't remember it. Maybe they slept through the whole class and maybe they didn't really see it. Or maybe they were left beside early. Who knows? But they've seen it before, right? The vocab's not foreign. So when I say collect like terms, eventually the strong vocab fixes the problem and I can move on. My life is not that difficult as a developmental teacher. So stuff like this happens and you don't see it right away. I have to fail the student because I didn't catch it soon enough. She's reading. 12 minus 5. She knows the like term. 12x minus 2x is 10x. Minus 6 plus 2. Now there's other things going on, but she is amazingly consistent. She has created an algorithm in her mind that she believes to be collecting like terms, because that's the only tool I had to give her. 8 plus 6. Oh, 8x plus minus 6. Sometimes we grab the sign, because we were working on it. By the time we got down to there, we were working on it. So let's see if we can see it. I put it in color. It doesn't always work. Why didn't the blue error show up? I have a blue error too. Do you see she's making 2 errors at once? And that was part of my confusion.
Oh, yeah. First, last step of combining like terms.
Yeah, if the variable's first, she knows it doesn't go together.
Yeah.
But if the constant's first, they go together. These were supposed to be in blue, so I could just point to them easier. If the variable's first, she knows they don't. If she's still just reading it. She's still just reading it. But there's enough there to build on. There's enough there to build on. So because there was a high enough level of correct computation, right? She got more than half of that pattern correct. There were strengths to build on. So the error was in reading. Not necessarily in consistent application. She was consistent in her own abilities. So I started color tiles, manipulatives, things that traditionally aren't even available in the university system, right? So, but she'd come to my office enough time for help. We tried that. She still had difficulty doing signs. especially when I had a sign problem and a like term problem together. So kind of like the error you noticed that wasn't entirely consistent. So if I go back up to this one, you know, with the 6 plus -2 gave the -4, it seems like she got it right. She still had some problems with consistency on signs.
And I was kind of surprised that she didn't, like in that first problem you had, that she didn't say that was -7x. Because that's what she was doing later, was anytime there was an x second, she was combining those
But
pieces
she
together,
never
but
got,
she wasn't doing that.
she wasn't doing that because she knew this had to go to the x. So she never got to this. I think that's the disjoint thing that I didn't see, right? Because I think then that would have made sense to me too. Because I've seen people where, you know, this is 5x, 2x, 4x, 8x. I know their problem is they just put everything together. But that wasn't her problem. But I didn't see it because it was dependent on what came first. Now we made some good progress. Well, after I gave her the manipulatives and tiles and gave her a repeat assessment, she did pretty good. A couple of sign errors. But for the most part, the numbers that were supposed to go together went together with mostly the right signs. This student still has lots of other, you know, issues. I think probably because I didn't recognize her as a first-time learner soon enough. I assumed that she had the similar background to the other students with similar test scores, and she really did. So that's what I mean by she was not typical developmental. So I don't know how much weight to put on this example other than I would suspect that if you're teaching signs, someone might read those signs across. And I never even would have thought to look for it. I really would, except for I was preparing for this talk. So I gathered that this week. So it did come out of this text, this Faujon gave me this book, Error Patterns in Computation. It's a lot of very basic stuff. Middle school, you'd say? Elementary school?
Elementary school.
Elementary school math. But as I was reading it to look for how to structure my talk, what kind of examples to talk about, make sure that if I were to give you an example about division, that I had other ideas that weren't necessarily the only things I could think of in case we came up short. That one was in there. So this is a common enough error to make it into print as you read left to right. And if it's persisting in our students, my guess is they're not getting the help they need because no one recognized the error. I should. Yeah, high hopes for that student next semester. All right, any questions? I think that's all I have. All right. Sorry to make you put away your thingies. I just wanted to see if you thought the error was pretty nice.
They have the same amount of powers, you know, they have,
Okay, so
they mean, it's just from left to right.
I don't know.
So say that they're the same thing and then they read it from it's 21st century. It is. Yeah. And they struggle with it.
And that was one thing that I struggled with too.
We gotta create a school.
Recognizing that, remembering that from me, I was able to say, it has to be in the language there.
And I've done that.
And I made them repeat it and write it and and lots of them.
But I like the idea about talking about it.